Okay, so this one's going to be going over a problem I've done previously, problem 31. So if you haven't already seen that video, probably worth going back and taking a look, but basically I'm just going to do it again, but I'm going to use recursion, hopefully, and basically just see how it can be applied, and hopefully get a neat solution. The other one I had like loads of nested for loops, so basically just looking at getting rid of that. Also figured I haven't done a video in ages, so it would make a nice one to put out. So let's get to it. Step one, we're going to define our main function. I'm just going to zoom out a little bit here, it's a little bit big. Now inside this, we're going to define our list of coins. So our coins, now these are going to have values of 1, 2, 5, 10, 20, 50, 100 and 200. Now we're going to have a total that we want to make, which in our case is 200, we want to make £2. And then I think that's about all we need to define. So then what we're going to do from here is we're going to call recursive solve. So we'll just call it recursive solve. We'll pass in the okay, so we need a current total. It's going to start out at 0, we don't have a total yet. And then what are we passing in? So we're going to pass in the current total, we're going to pass in the total and those two coins. Now let's go define, you'll notice I haven't actually set recursive solve equal to anything or whatever because I'm not actually sure what it's going to return yet, but we'll get there. So recursive solve, let's copy this, why not? Okay, so this is going to be the thing that calls itself over and over to find a solution. So what it's going to do is it's going to say so for coin in list of coins, the total is now equal to plus equals coin, so it's now equal to its current total plus the value of the coin. And then this is where our logic will come in. So if the new total is equal to our whoops, so it's not going to be total, this is going to be current total, and if current total is equal to, we'll call it our goal, this will make things easier, so we'll get rid of total here, call it goal. So if we found a method of making our total, then we're going to say so what's the goal? The goal is to find a number of different ways that it can be made. So what we're going to do is we're going to have a variable called number of ways. This can be 0, we have none to start with. Now we're going to pass this in, and what's going to happen is every single time we find the total, we're going to say number of ways plus equals 1, and then we're going to return the number of ways. So we know we're returning a number of ways from this function, so we're going to say number of ways is equal to that, and then we want to print out that answer. So if our current total equals our goal, then we've got a way of making £2 with the coins, so we'll return the number. If So if the current total is bigger than the goal, then we know we haven't got a solution, and we know that we're never now going to get one because we're always adding to our total, we're never taking away. So we've now passed it. We know this isn't ever going to lead to sort of a new way of making £2. So we're going to say just return, and we're going to return the number of ways that we already have. And then finally, nothing else. So if we haven't hit our goal, we haven't went over our goal, then we just need to iterate again. We need to find out. So basically, we need to like branch out again and make all these new ways. So else we want to do. So we want to say recursive solve again with our parameters passed in. And yeah, that should be it, I believe. So what we'll do, import time, and then we'll say start equals time, in, and then print time taken was seconds dot format. Actually, yeah, dot format this. Okay, so what I'm going to do is I'm going to drop the goal to something small, so it's going to be 10 for now, just so we know that it runs quick, so that we find if we've made any mistakes. So we've obviously made a mistake here, getting the answer of 0, just the code you missing off screen right there. So yeah, we're getting an answer of 0 down here. This is the answer. So clearly something's going wrong, but what is it? So what I'm going to do is each time this is called, I'm just going to print out the current total to see what this does. Okay, so we get a bunch of stuff as you'd expect, but it seems that once it hits the so we're never actually getting anything over 10 here, you'll see, whereas we should be getting things that are wrong, because you'd get something that's wrong and then you'd step inside the this elif right here and you'd return it. What I'm going to do is just down here, I'm just going to try return the number of ways, just see what this does. Apparently not a lot. Okay, so let's go through it. So if we say our goal is, we'll say 2 pence, okay, because we know the answer to this. The answer to this is you can make it by adding 2 ones, or you can add 1 2. So only ways out. We expect our answer to be 2. So you'll see we definitely don't get that, and we only step inside 3 times into this recursive function. So let's go through this logically and see, do we expect that to happen? So if we pass these values in, so we're going to print the current total and we pass them in first, so we print 0. That's correct, we did do that. Now we're going to say for coin in list of coins, so for each one of these, the current total plus equals coin. So perhaps this is where we're going wrong. We should maybe define new variables right here. So put new current total, and then we recursive solve on a new one. See if this solves it. Nope. Okay, so equals current total plus coin. Okay, so we're getting 1 now, which is obviously better than getting 0, but we're still wrong. So now I think it's just something to do with stepping out of it like 1 too early. So what I'm going to do here is just print out a blank line, because that just confused me where I thought we had 3, but you'll see we're just stepping into the thing twice and then getting the answer of 1. Now, why is that happening? So the reason we're stepping twice is because the first time we're not equal to the goal, we're also not bigger than the goal, so we step into it again. There's the second time. Now the second time we come in, every answer we get, so the first answer we get is we get 2 because we've stepped into it by having coin equals 1, and then we come back in, coin will equal 1 again, add on to it, so we get 2, then our number of ways increments, and we return that, so that's where we get our first increment from. Now once that's returned, we reach the bottom and then start again, so our new current total would then be added to again, which we don't want to be doing. We need to redefine this every time we come back to the beginning, I think, which we actually are. So why is this going wrong? What I'm going to do is I'm going to print right here the current total right there. I'll also print out, so we'll put like a here and here too. Let's just see what these do. So we step into the main function, step into the loop, step into the function again, step into the loop, so this is all as predicted. Then we'll go back through the loop, but somehow our current total now is equal to 0. Now why is that? Is that right? That might actually be right. So yeah, that is right, because at this point we've came back to this line basically but incremented the coin, so I could print right here the coin value just to see that. Oops. Yeah, so our coin is now 2. Now with our coin being 2 and our current total being 0, why is our new current total then not equaling 2 and giving us the goal? So let me just print out the goal, and down here let me print out the new current total. So my guess is we're actually stepping inside this. But maybe the number of ways isn't remembered. Yeah, that would make sense. So the whole problem was that the recursive solve function was just being called, it wasn't actually being set to anything. So we need to say the number of, the number of ways is equal to that. Now we should be able to just comment these out and it should all work, hopefully. So yeah, we get 2. Cool. That was a very simple bug that took quite a while to debug. So now if we up this goal to say 100, does this take ridiculously long to run? None type. Okay, so when this is ending the loop, it's returning a none, whereas what we want it to do when it ends the loop is return the number of ways, I would imagine. Is that right? This is going to take a while to run by the looks of it. Let me try dropping the number down. So try on 10, just see how it goes. 129. Now I actually have the other file, so what I'm going to do is I'm going to check the numbers against this one. Or am I? No, this one isn't very easy to change. Okay, so let me just adapt this one a little bit. So we're going to have a goal right here. This is going to be equal to 200. Now anywhere we see a 200 we can replace with goal. As you can see, this one was awful, that's why I wanted to change it. I'm not so sure, I could have changed that one. I think that had to be a 200. It was the thing here that we would want to change. Okay, so if I change this to a 10 and then run this, I get 11 different ways to make it, whereas I'm getting 129, which makes me think I'm getting multiples. So it makes me think I'm doing like, so 1, 1, like 5 ones and then a 5 would be a different combination than 5 and then 5 ones, which isn't the case. So I just need to stop them duplicates happening, which to do that, how do I do that? So I need to, once I step inside, never be able to have a smaller coin come afterwards. It could only ever be equal to or less than. So I need to pass in the list here. So list to pass is equal to, we're going to call it list of coins, and then we're going to say list to pass I don't know how I do this without doing a loop. There must be some way of, just one sec. Okay, so I'm just going to loop over and just remove them all. So for number in list to pass, and a list of coins, if number is less than coin, so remember the current coin we're on, then list pass dot remove coin. Now I think that will work, and then we just want to pass this list in instead of list of coins. Now, does that give me 11? No. How is it not in the list? Okay, so the second iteration, maybe it's not in. So what I'm going to do with this is just try and accept it. And yes, I'm just going to accept pass because I cannot be bothered making an actual exception to catch it. Now we're getting 3. Interesting. What I could do instead is, instead of doing this, I could check up here. So if the last coin added to my list was bigger than the current coin I'm on, then I'll just continue the for loop. So if the list of coins, the last entry is bigger than coin, then continue. Let's see what this does. Whoops. Zero. Cool. Let's see what small does, just out of interest. 129. How am I getting the same answer? Oh, it's not a list of coins, sorry, it's... so I need... Okay, so last coin, we're going to call it a 0. I'm going to pass this in to there. I'm going to pass it into there, and then here it's going to get passed coin. And then if the last coin was bigger than the current coin, then continue. Okay, that makes sense. 11, there we go, finally. Okay, so let me just run the other one. So 11 there and 11 here. Now let me up the number to 50. See how quick that runs. Pretty decent. Up it to the 200 that it needs. Not bad, 6 seconds for 76,000. Now let's just check that answer's right. So 200. So we're looking to beat 6 seconds, and the answer is 76,000. So it took us 10 seconds and 76,000. So we're right and it's quicker, so perfect, exactly what I was hoping for. It's also a lot more elegant. As you can see, this is horrendous, and this eventually in the end is quite nice. I probably didn't do the best job of explaining it while I was doing it, because obviously it was pretty confusing just to be doing it rather than explaining it as well. I didn't want to be explaining stuff that was wrong. So let's have a read through it, try and get your head around it. The thing that sparked this was something like another project I'm working on. I basically use recursion in it, and I really like it, even though it's really complicated all the time and it's really difficult to understand exactly what's going on. It's really powerful, and it's probably my favourite coding technique at the minute. I really like the idea of just telling it to call itself repeatedly until you get the answer. So yeah, this bit here is probably the most confusing bit I would imagine for most people. But this is basically just to stop all the different permutations coming out, and instead of giving us permutations, it's giving us combinations. Does that by just making sure that all our lists are in ascending order of coins, because obviously there's only going to be one version of each list of coins that is in ascending order. The rest will all be different permutations of that, which won't be in ascending order. So yeah, that's about it. Other than that, I think I do hope to do some other recursion stuff, but obviously it's as it comes up. I'm not too amazing at it, as you can tell. Made loads of mistakes here, so just keep an eye out. If I find any other good little problems for it, I'll probably make a video on them. And yeah, that's it for now. Thanks for watching. I'll see you in the next one.